Welcome to RIP Routes. Let's take a look at RIP Routes here for a few seconds. RIP's a little different than static in that it gets the information from the routers. Again, routers know about routes that are directly connected to them. So when we start the routers up, router 1 knows about the .2.0 network and the .3.0 network. That's connected to it. Router 2 knows about the 4.0 network that's directly connected to it. What RIP does is allows router 1 to tell router 2, I know how to get to 2.0 and 3.0 because they're connected to me. And router 2 sends the information to router 1 and also to router 3 once we configure the protocol to tell it that it knows how to get to network 4. So after we send this information, after router 1 sends its information to router 2, in its route table it now knows how to get to 192.168.2.0 and 192.168.3.0, and we've added 1 to the hop count, and also knows how to get to 4.0. It's directly connected. These both should be 1.5, which would be the address down here on this interface, which tells the router to send information to the 2.0 and the 3.0 to the 1.5 address. Once router 2 shares its information with router 1, router 1 now knows how to get to the 2 and the 3 because they're connected. It also knows how to get to the 4 because the RIP protocol information from router 1 says, hey, I know how to get to the 4 network, and we do that through 1.6, the 1.6 interface. If we added the other routers, they would do the same thing. They would share the information. So effectively what these guys do is tell everybody, I know how to get to what's connected to me, and as they share information, they also share the information that's shared from the other routers, hence the routing by rumor, because I'm telling you that I know how to get to somewhere, but that's only because somebody told me, some other router told me that I know how to get there. So that is the way basically that RIP works. Now let's go and configure some RIP routes on the route. Okay, we're on router 1. I think that one of the easiest ways to figure out what you're going to advertise is to show an IP route. When there's nothing there to this point in time, there are no static routes, there are no dynamic routes, we have the directly connected interfaces. And these are the ones that we're going to advertise. So we will go to config T, router RIP, and then we'll tell it which networks we're going to advertise, 192.168.1.0, and RIP is a class full protocol, so that we're not going to use any subnet masks. And oh, by the way, since it is a class full protocol, I can't use what I used on the static routes, which was a subnetted 192.168.1. I have now added the one network here, the 9 between routers 2 and 3, 10 between 3 and 4, 11 between 4 and 5, and 12 between 5 and 6. So that's not going to be very efficient in the use of IP addresses in the subnet world. Again, RIP v1 is class full, RIP v2 is class less. The configuration is very similar for each of those. So we're going to advertise the 1 network, and again using the up arrow key, the 2 network, and the 3 network. And then if I go to show IP route, I still just have the directly connected because there's nothing that's sharing routes with it. Let's go to router 2 and see if we can get some routes here. Show IP route, and it shows us what's directly connected to it. So let's go to router RIP Nope, got to be in config mode. Router RIP network 192.168.1.0 and 4.0. Again, the up arrow key and 9.0. Show IP route, and we now have RIP routes already coming in. So it now says that I know how to get to the 2.0. 120 administrative distance is the administrative distance for RIP. Directly connected is 0 and static routes are 1. So an administrative distance is basically how well the route's trusted. Each protocol has its own administrative distance. RIP is 120, which is going to wind up being the least trusted of all the protocols. So what it's telling us is to get to 192.168.2.0, we're going to go out serial 00, which is, in fact, we do. Going out serial 00 is the same thing as telling it to go to an IP address. So we can tell it which interfaces to go out of. I'm going to go ahead and pause this and configure RIP on the other routers and see if we can get across the network again. Okay, I've configured the rest of the network with RIP, and I've done a show IP route here, show IP route. We get the same information here. We have the directly connected, the 3 directly connected, the 1, the 2, and the 3, and then we have RIP routes to everything else. And you notice that each of them goes out serial 00, which is exactly what we did in the static routes with our default route. If we wanted to use dynamic routes and static routes together, we can. Dynamic routes don't advertise static routes, so we can do route exceptions while we're using these protocols. Let's look at one of these in the middle. Let's look at router 4. If we do a show IP route, R-O-U-T-E, then we have RIP routes that go to 1, 2, 3, 4, 5, all go out serial 00, and we have 6 directly connected, and then 7, 8, and 9 all go out serial 01. Well, 9 goes out serial 00, so 7 and 8 over here go out serial 00. And then we have the directly connected networks, the 10 and 11 on serial 00 and serial 01. RIP, very, very simple to configure. If you don't get routes fairly quickly, you need to look and be sure that you've advertised the networks that are between the routers. If you don't advertise those networks, they can't share the information. And again, the quickest way, in my mind's eye, to figure out what you're going to advertise is before anything is there is to do a show IP route, type the show IP route, and then you go to configuration mode, router RIP, and then the network commands for the directly attached networks. Once you do that and the RIP routes start showing up, you're in business. Again, it can only use complete networks. It is a class full protocol. It does not recognize subnet masks. So what I had to do to change from the statics, waste some IP addresses, is to put a class C network between the individual routers. RIP, simple to configure. All dynamic protocols work in the same sort of conceptual way. Each of them shares information in a different way. RIP shares the entire routing table every 30 seconds, so it's kind of a chatty protocol. Just to show you the chatty, I paused it there for a second and turned on debug IP RIP, and then we get some broadcast traffic, some route sharing information. RIP received, RIP build, RIP sends update. So you can use the debug IP RIP in order to see what it is sending. And here we go again with a whole bunch of other things. And the metrics, 1, 2, 3, 4, the metrics are how many hops away each of these routes are as it sends it the information that it has to the other routers. I know how to get to something and it's this far from me. This would allow you to have multiple routes with RIP, and it would use the one with the fewest hops. Remember, RIP only uses hop count, pays absolutely no attention to anything else. To get this off, we could type the no debug all, which is probably the quickest way to get it out, so that we don't get all of the debugging information. No debug IP RIP or no debug all should each of those commands should stop the debugging. That is RIP configuration, kind of what it does, shares information among routers using a routing protocol, RIP. And once it's done, if we change the topology, something happens to the topology, we'll get automatic updates, and that information will be automatically updated. So RIP, the simplest of all of the dynamic protocols. Hope this has been useful, and thank you for watching.